now. So, LK-99. Does this mean that we're now super metal alchemists? I don't know. Wait, what's this? Oh wait, hold on. This is a paper. It's on the archive. Supplementary materials, material and methods, sample to synthesis and preparation, yada yada yada, were uniformly mixed in a mole ratio of 1:1 in an agate mortar with a pedestal. I don't know. I think it's a very interesting time. You all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper Rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper Rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So apparently we had a video the other day and people were going back and forth, and then Dr. Hassenfelder, she gave her opinion. She's like, yeah, no, I think this is, was it some super dielectric effect or something? Perhaps. Now, I am cautiously optimistic. Again, healthy skepticism is good, but again, if this pans out, this literally loves up humanity. This is like one of the things that we need to maximize transport of power, which also will help different experiments. Like, I don't know, maybe actually getting fusion integrated and deployed around the planet. So I don't know, maybe we don't need to be as mean to Mother Earth. I'm just saying, I occasionally don't like having things poked into me without my consent. I'm just saying. But but basically, this actually came to us from Reddit here. And again, take it what you will. That's why I say we conjecture ahead. But we go to our friend Reddit here. Okay, so we'll embiggen you a bit. All right, and you are embiggened. Okay. So basically, they're saying they actually have a translation. That's the claim. Take it for what it's worth. From the actual Korean journal that they published it in, and there's a translation here. All the links in the doobly-doo, but the first couple were one for the picture from the New Scientist there. It's in the link. I believe this is the first archive, or is this the second? That's on the 22nd. This one was also on the 22nd, last revised July. And again, there was controversy. Somebody said they didn't know, and then there was only like one name on a paper and stuff, and people were going back and forth. But essentially, the claim is that this compound, which they literally give you the directions right there, it's literally, I'm not going to say it's as easy as baking cookies, because it's literally chemistry that apparently, at least according to Anton at one point, he hyperbolically said, so it's magic. There's one thing I've learned from Professor Keating, and that quote from Arthur C. Clarke, it's that any sufficiently advanced technology is indistinguishable from magic. But long story short, the whole point of this video is I actually went into the paper and I'm like, okay, I am not a chemist. I'm not a professionally trained physicist, mathematician, or anything like that. I am a dude on the internet. Full disclosure. But I've had the benefit of talking with some really smart people. Some of those who may be watching now, or temporally in the future. But hey, no, thank you for joining Man Squatch, as well as a Fractal Automata. There's some very interesting things. Dude, I go back to some of like those earlier, what was it? The Iranian or Iraqi battery or something like that. You see some of those things that's going on, it's like, how did they know? What's going on? And again, I haven't really looked into that, but I've heard some very interesting stories. And again, just do your own research. Talk to some professional folks. Some folks may shy away from things that might not be as many people are talking about. I tend to feel like that's the same, depending. It really doesn't depend on discipline. That's just things in general. Just my observation as a dude, in my opinion. Hey, Snacks. So essentially, they basically took, looks like lead and copper. Literally, they took these different chemicals and everything, these different compounds. They like ground it together in a mortar and pedestal. They mixed them together, They literally baked it, I think, like 900 something degrees for like a couple of days, and then they did something else to the other stuff. And literally within about a week, but this is based upon a lot of research. That I think they originally discovered something similar to this back in like '99. So that's like 20 something years ago. They've been working on it. But it's exciting stuff if it is true. So what we're actually going to get into is here are the papers here. Just real quick. Okay. For a sample synthesis, the general solid state reaction was used. So lanarkite, I don't know what that is. And that looks like a copper 3 with phosphate or something on it. Were uniformly mixed in a ratio of 1 to 1. It was sealed under a vacuum at -5 torr, whatever that means, 925 for 10 hours. Oh God, it sounds like I feel like I'm a hybrid between like How to Cook and then like Breaking Bad. Drugs are bad unless prescribed by an appropriate physician and distributed by a multi-billion-dollar pharmaceutical company, because that's the way we do things. But so basically, they're literally just combining these things, but that's not what we're going into. But essentially, and again, feel free to check out any of these links and everything down below. And again, this is my conjecture as a crazy person on the internet, but they basically have the third paper. Nobody ever docks themselves on the internet. There's a third LK-99 paper that was much better, and that brings us to here. And somebody uploaded this to GitHub. So again, take it for what it's worth. But I was just going through and I looked at some numbers and everything. So I'm like, again, there's a better version. It looks like it. I believe it's the same translation. And again, it's brought to us by technomancers.ai. Take it for what it's worth. Be wary of clicking links on the internet. There's a disclaimer. But it doesn't have all the cool pictures. But we just go back to this guy for just 1 second. Okay. So basically, they're saying that maybe some folks just miss things, and they're essentially treating the electrons and superconductivity just almost as like a liquid state, which is very interesting because I heard this talk about a superfluid, but we must remember, but no ether. It's totally not the ether, even though we're describing things that sound a lot like the ether. No ether. Disclaimer aside. So what do we have here? We have 2 pi. Well, that's a circle. Okay. Times h bar. Okay, so that's basically just Planck's constant itself divided by E, which I believe that's the charge of the electron. See, this is a confusing thing because it could be Euler's number, could be the mass. No, it would be M. So that's basically the charge of the electron, I believe, because it comes out to be was it 4.135 times 10 to the negative 1 Gauss times centimeters squared. I don't know about you, but I had no idea what that means. I still don't really know what the heck that means. But hey, T Carr, thank you for joining, my friend. These are exciting times. And also, one could say, just because of some of the drama going around about like the red stuff thing that came out, and then somebody had apparently either manipulated data or those fraudulent things, and Nature's retracting 2 articles. So, of course, people are going to be skeptical. Then at the same time, if somebody's actually bold enough to actually do this, it's like, all right, if this is falsified, like if you just made this up, yeah, your careers are basically over. So it's like, and they did actually bring on one of the more noteworthy gentlemen as well for clout, to overview, to make sure they're not just crazy people like me. I don't know. But we have this number here. I'm like, that's cool. What does it mean? So go to our friend Wolfram Alpha. I just type in the number 4.135 times 10 to the negative 1 Gauss times centimeters squared. Okay. Gives us these numbers here. Units of Webers. What the heck is a Weber? It's also equivalent to emus. I apologize to my friends in Australia. They kick butt, those emus. It's a hyperbolic statement there. But Mansquatch, here's the thing. I believe even Dr. Weinstein said this at one point. He said, every once in a while, our lunatics might be right. I did a clip on it. Professor Keaton held a Twitter Spaces, or X Twitter, which is now X. This is a very you can't write reality. This is, or maybe you can. I don't know. Who can? Ooh, Tyler's resonating with me now. Okay. So what the heck does this mean? The interpretation. Magnetic flux. Something, electrons moving at a fantastical rate. Magnetic flux. Imagine my shock. So basically the big thing here is we have unit dimensions, okay? So it's mass times length squared times time to the -2 times current to the -1. What's that mean? Mass, length squared, and then time and current are in the denominator. So time would be squared, and then current is basically it's a derivation of, was it the charge, length, and time? I believe something like that. But thanks to Wolfram Alpha, it also has that 2 to the 6, which is kind of neat there. I actually don't even know what that means, but when you toss those things, let's go over to Weavers. Shall we? Oh, no, oh no, we skipped ahead. Oh no, I skipped too far ahead. I apologize. I'm ruining it. Okay, we go over to our friend. So it's 10 to the -9 in Weavers. Whatever a Weaver is basically that unit right there that we were just talking about, using our dimensional ingredients, which, according to Thad, and apparently according to Wolfram Alpha, the constants of nature as we know them can be made up of 5-dimensional ingredients: time, space, charge, mass, and temperature. It's very interesting. Weren't there like 5 main types of string theory? That's for another video. I'm not a string theorist. But, okay, so we got this number here. That's cool. Can we compare it to anything? And again, this is just rampant conjecture on my point. So I looked at those dimensions. I'm like, what are the Planckian boundaries? Shall we? Oh, we shall. So over here, what do we have here? All right, so Planck mass, Planck length squared per Planck time squared per Planck current. So those are in the denominator. Okay. Comes out to be this number here. What is this? 5.623 times 10 to the -16 kilogram meters squared divided by seconds squared per ampere. Oh my God, that like makes my head explode. Okay, wait, okay. Oh, that seems to be a very small unit of magnetic flux quanta. Cool. Oh, it's in volt seconds as well. It's the equivalent. How about we do the Weavers like we did before? It's 56 Atta-Weavers. Atta-Weaver. Okay. 56.23 Atta-Weavers. Okay. All right. We have that. It's a number. That seems to be a smaller number. How many of that number go into the other number? Just I had a question. Okay. So it gives us 10 to the negative. Where are we? Okay. That number. I just want to make sure I have these right. 5 times 10 to the -17 Weavers. -17 Weavers. Okay. God, I feel silly for just saying that. I love science. Okay. So what happens if we take the difference of those? We take our 4.135 times 10 to the -9 Weavers. We divide it by 5.623 times 10 to the -17 Weavers. Oh, actually, hey, hold on. This is the number you get. I got that number and I'm like, oh, 7.354 times 10 to the 7th. 10 to the 7th power. It's very interesting. A lot of the binomial factorization equations based upon the Planck mass times the Planck length divided by the Planck charge squared, which coincidentally comes out to be 10 to the -7. I mean, that's kind of cool. I know, Fractal, it just keeps seeming to pop up. might we learn in the near future what's going on? I guess time will tell. What I actually did was I'm like, all right, that looks was a circle 6.28 pi, and again, this is just full just conjecture on my part right here. When you divide it by that, it's like, oh, 2 pi. Well, number one, that looks kind of like around Planck's reduced constant. It's 10 to the 8. Again, pretty close to 10 to the 7, a higher number of that. I started looking for close forms for this. And again, this is just rampant conjecture on my part. But when you type that number into our friend Wolfram Alpha, and again, the power is the power for whatever it is, the first thing that caught my attention, I'm like, oh, look, pi divided by e. The primary constructor that we use for circles, and again, you could say it's half a tau. We have to be fair. Divided by the base of natural logarithms. I mean, that's cool. You get 8 divided by pi, and again, these have varying degrees. Secant squared 3/8. Oh, okay. Cool stuff. Oh, look, pi divided by. And then I notice this guy here. I'm like, 2 divided by the square root of 3. Didn't we do something with the square root of 3 or the reciprocal of a square root of 3 not all that long ago? I think we did. Where was it? Oh, did I have it here? Where was it? Here we go. I simplified this because I realized that whole tetrahedral angle divided by 2, it's literally just the magic angle, or 2 whatever it is. So any of the tetrahedral angle divided by 2, it's literally just is the magic angle. So it's a little even more magical, so to speak. So what I did was, it's basically the secant of the magic angle, and then if you throw the 2 in there, that gives you 2 over the square root of 3, which I thought was kind of cool. And then I started looking at these forms here. I'm like, okay, is there anything going on? Oh, did I skipped ahead, didn't I? I apologize. Shh, don't look. But I thought that was pretty cool. I think, did I even find? Okay, so we got the same standard things. Oh, look. Oh, Trot's constant, this, that. All that other cool stuff. Okay. One of the other things I noticed is, and again, just this is something different. This is actually just 1 degree, but within twisted bilayer graphene basically you have those hexagonal, like atom thick, technically lattices, more or less. You take each one of them and you adjust them by 1 degree. There seemed to be some overlap there in a particular way. And the first thing I tried to do is I just ran out of time. It was getting too late. I was going through and I was trying to run, because I had taken something from one of the papers on this multi-layer graphene, threw in the Wolfram Alpha, and literally showed a vector field of just things like looping around. It's like, okay, swing your electron round and round, and where it goes, who knows? It's apparently it starts to show superconductive like properties. Hey, sheepherder, good to see you, my friend. Thank you for joining. But the last thing I just want to show real quick is we go back to our little paper here, and I apologize. It's the better version is linked next, but this one actually has the cool little graphs and everything. And apparently the newest one, it actually shows some of the drop-offs from some of the measurements. So again, take it for what it's worth. I would say exercise skepticism. Apparently those things, you're seeing a particular drop-off at a particular, what is that, temperature, Kelvin and everything. And that's the specific heat, is that calories per Kelvin, I believe. And again, do I really know what any of that means? No, there's a lot of smart people though. But where was it? Okay, the ratios of different things. Okay. Actually, hold on. Let's go back up. I forgot to review the one paragraph right here. Okay. So they're basically trying to set, okay, what is that? Time, limit, fit, or whatever it is. It's like the A, which is, I believe, is area is 1/2. Because apparently for electrons, and again, correct me if I'm wrong, when they're entering like the same energy level, whatever shell it is, typically they want to be going different ways for either angular momentum purposes. Like if one's technically spinning, I don't even know if that's the right term. One way, the other's going to be going to go the other, so it's going to kind of form together something more simple. Otherwise, they'd rather just chill away from each other. Okay, so later in the superconducting insulator, superconducting junction, S plus S junction, tunneling experiment by Josephson, number 12 citation. The assumption that two electrons are involved in is established as an established theory through experimental proof. Citation 1415, that the default value, magnetic flux, oh, that was the quantity we got earlier. Cool. Middle of the voltage increases per quantize the electron is according to equation 3, which is half the magnetic flux value divided by equation 2, predicted by the classical point of view, calculated by Landon or London, I apologize, in 13 there. So, okay. And I'm skipping a lot. I haven't read through this paper. I've literally just kind of gone through. Okay, maybe I read through some of the other proofs and stuff a little bit the other day. But where is it? Okay, here's the very interesting. Section 1.3, how to raise the critical temperature. One-dimensional electron structure and electron correlation. What is noticeable in the new approach based on the aforementioned basis is that it's important to have a low-dimensional 2D or 1D, etc., electronic structure that severely limits the number of electron states. Okay, you want it to be as simple as, that's why they aren't using the graphene, because basically it's like, basically just two dimensionals more or less. It's like, you can only go so many ways. You're limiting the degrees of freedom. Okay, that makes sense to me. Electronic structure that severely limits the number of electron states in order to increase the critical temperature under normal pressure. All right, cool. Theoretically, as the critical temperature of a material decreases in dimension, the following ratio is calculated. Okay. 3D, 2D, and then 1D. So 1-to-1, I don't even necessarily know what this means. I think they're talking about from reducing it down from 3-dimensional to 2-dimensional to 1-dimensional. Basically, they had a ratio. I looked at both of these. Did I have the other one? Was that 1.25? I don't think I include that one because I didn't really find much interesting right off the bat. But when I took that one and that ratio 1.767, and they have a colon there, so I'm not sure if that's still going on. That's error or something. But I took that 1.767. I threw the ratio into our friend Wolfram Alpha. Okay, was there anything of note there? Let's see. Gives us this number, and these are just approximations. So again, if we only have 4 significant digits, it is what it is. But there's some very interesting recommendations that I noticed. So what do we got here? 9 pi over 50. Oh, look. 2 times the square root of 2 divided by 5. I think if we have a 1 plus that in there, isn't that like the golden ratio? Something like that? That's cool. 40 log divided by 7 pi over pi, 549 PC bond index. Oh, it's Ferrois Ferberduce. That was pretty cool. Constant divide by 8. And again, these, as you can see, these only have like the first like 3 or 4 significant digits. Technically 0 here, so about 3 significant digits. 3 times the natural base of logarithms. Okay, that's cool. Oh, CVI divided by 2, that's cool. 6 by the lambda. Oh, that's the mean disk ratio. That's 5 and an 8 there. See another ratio divided by 5. I mean, that's some cool stuff there. What if we looked a little further? We didn't need as many significant digits there. Okay, we take it off. Let's lower our parameter space a little bit. See if there's anything cool. But hey, Gap. Hey, Danny. What's going on, my friend? Good to see you. Well, dude, I'm really starting to like relearn like geometry and trigonometry because it's so valuable. It's like I kind of learned this. I never felt like, oh, what am I going to use this for? Now it's like, Oh my god, this is invaluable. Why did I not learn this stuff? There's a lot of reasons for that. Mostly my fault and laziness. But as we explore the computational universe, might we find something that catches our eye? So as we go down, oh, the mean disk something divided by 2. Wait a second. VFE raised to the 4th divided by 30. VFE. Wait a second. VFE is a figure 8 knot hyperbolic volume. Cool. Now, is there any interpretation? Now, I am totally biased. Full disclosure, as somebody that's an intern at the physics monastery, which, full disclosure, the model we are using is primarily based off of a number of things, but with the primary object we're basing the model off of is the hyperbolic figure 8 knot. It's a double cover of the minimal non-orientable free manifold, the Geesking manifold, but it's very hard to find any actual decent pictures, which happens to have a Kleinian bottle structure. Its first homology group is the integers. It's made from idealized tetrahedra, and the figure 8 knot is a double cover of that. But I noticed this construction, and it looked a little familiar. Have I talked about this before? What's this? I'm going to geometrically calculate the mass of the electron. Oh, that was from 6 months ago. Cool. I updated the equation in the thing there because I've learned more about Wolfram Alpha, so I literally just need to type in figure 8 knot hyperbolic volume to get this. See, I literally had like the whole gamma, the 3's, and the square roots and everything. Oh god, it was abysmal. This looks a lot neater. Okay, so in order to calculate the mass of the electron, can't make this up. Can't make this. And again, full rampant conjecture on my part here. Happens to be the primary action is 2 volumes of the hyperbolic figure 8 knot. Okay. Times the boundary, which in this case is the Planck mass boundary. Well, that's raised to the 4th. So orthogonally set up. Huh. And then we have our terminal action, which is 1 plus 1 over that. And it's basically times the hyperbolic sign times the 10 to the negative 7, which is Planck mass, times Planck length, divided by Planck charge squared, yada, yada. And then that happens to be the number of derangements, so exclamation point 0.5, which is 44, divided by the break and scale symmetry 7 of the model. So it's hyperbolic sign of the hyperbolic sign. You can double check it. This, I believe, hits it to all the significant digits we have there. Oh, what was it? No, don't mind me. I was listening to Denver, the Last Dinosaur. So I just go back here. I'm like, all right, 2 volumes of the figure, hyperbolic figure 8 knots. Raised to the 4th. What are we doing? Oh, volume of hyperbolic figure 8 knot. Raised to the 4th. Let's divide by 30. And again, rampant conjecture on my part. How do we get the 30? Well, according to the FADS model of the minimal arena, or the HF8 model, you have 5 dimensional ingredients. Okay. That make up our realm of persistence, apparently. Where could we get a 6? We go back to our paper. Actually, yeah, we go back to our paper. Because some of the diagram, and there are some higher res diagrams in other places and everything. So, but apparently the whole thing is when you actually look at the alignment of the lead. Basically, you have lead and copper, and then that allows it to shrink down. I think like 0.5% or an extra percent when they're going through like the vacuum and the preparation process. So it's getting down closer to different atoms and everything, apparently, to a particular state that form kind of like triangular cross sections there. Basically, apparently, these are channels that, if the claim is the electrons can start to flow through in a particular way. And I just start looking at some of these structures and I'm like, so if you're just squeezing this stuff down into more of like a two-dimensional structure or limiting its degrees of freedom as much as you can, once you start getting some current going through there, especially if electrons like to kind of go different ways, kind of, isn't that what Cooper pairs are? If they're like, I'm going this way, you're going that way, once they start flowing, is that how superconductivity works? Now, full disclosure, I have no idea. It's a rampant conjecture by a crazy person on the internet. Hey, Sebastian, can it be real? Could be. I don't know. I guess we're going to have to see. Hey, Metallicus, yes, we are attempting to do the science, or at least notice some very interesting things. And again, this is some of the reasons why. And again, I tend to be an optimist. Why? Because I can. I think we need some more positivity in the world. But if this stuff is true, this really is a game changer. So I guess we're going to have to see how it plays out. I just played around with some numbers again. Probably nothing. It's not nothing. By definition, doesn't that mean it's something? And I think that's all we can really ask for right now. Oh my God, I'm babbling on for over half an hour about superconductivity. Oh, I need to go back to school. Well, I guess that's why I'm going to a monastery. Try to learn stuff and things. But yeah, I appreciate that you're appreciative, Fractal. But that's all we got for right now. Peace out, everybody. Take care of yourselves. It's a wacky and wild world out there, but it's open for a better tomorrow.